Hey guys, welcome back. So today we're going to be doing problem 17 from the prelim 2 review for CS2800. I'm planning to be a course staff, so I gotta turn this video in. Let's get right into it. So the hat check staff had a long day of serving in a party, and at the end of the party, they simply returned the n-checked hats in a random way such that the probability that any particular person gets their own hat back is 1 over n. Let x sub I be the indicator variable for the ith person getting their own hat back. Let s sub n be the number of people who get their own hat back. Part A is asking, what's the expected number of people who get their own hat back? So just from reading the question, we can tell that they want us to say that x sub I is a Bernoulli random variable with parameter p is equal to 1 over n, and s sub n is equal to a sum of x sub i's, where there are n of them. Okay. And so for A, we're asked to find the expected value of s sub n, which is simply the sum of the expected value of n x sub I Bernoulli random variables. Maybe wondering why is this true? Linearity of expectation always applies, even though the x sub i's are not independent of each other. So this is still legal. So this is just n times the expected value of x sub I, which is just 1 over n, if you remember. So that's just 1. Perfect. Moving on to B, we're asked to find a formula for x sub I times x sub j, where I is not equal to j. And for this, we just have to remember that x sub I and x sub j are both Bernoulli random variables, and therefore their product will only be 1. Their product is 1 only if both x sub I is equal to 1, which is equal to x sub j. And that only happens where person I gets their hat and person j gets their hat. So it's just condition on the first one. The x sub I, the probability that person I gets their hat is 1 over n. And then the probability that person j gets their hat, given that person I has already gotten their hat, is 1 over n minus 1, because, you know, they're n minus 1 hats remaining. And person I already got their correct hat, so there's like an equal chance that person j can get their hat, but only out of the remaining n minus 1 hats. So that's just 1 over n times n minus 1. Perfect. Part C is asking just like a conceptual question. Why can't we calculate the variance of s sub n as the sum of the variances of the Bernoulli random variables? Now, what you just got to remember for this one is that although linearity of expectation always applies, you can only add the variances if they are independent. So the answer to this is just that the x sub i's are not independent. Okay. D is asking, what's the expected value of s sub n squared? Or show that it's equal to 2. So that's just asking the expected value of this sum squared. Now, by expanding this sum, we know that there are going to be a bunch of terms that are just x sub I squared. And there are going to be some cross terms. X sub I times x sub j, where I is not equal to j. Now, for this first one, we know that there are n x sub I, so when you multiply polynomials together, you're going to get n things that are squared. So that's just n times the expected value of x sub I squared, which is equal to n times 1 over n, which is equal to 1. Now, the second one's a little more tricky. We want distinct terms in the sum. So we know that there are n things and we need to pick 2, so we can just do n choose 2. But when you expand it, that will appear twice, so you want to multiply that by 2, which results in n times n minus 1 possible terms. So n times n minus 1. And now we want to multiply that by the expected value of x sub I, x sub j, where I is not equal to j. And from earlier, that's just 1 over n times n minus 1. So that is, I'll just write it out. It's equal to 1. So adding the 2, 1 plus 1 is equal to 2. Beautiful. And now part E is asking what the variance of S sub n is. Now, if you remember, variance of S sub n is equal to the expected value of S sub n squared minus the expected value of S sub n quantity squared. We know that this is just 2, and S sub n is 1. Let me just write, what am I doing? So that whole thing is just equal to 1.